Mniej więcej 19:30, oczywiście wszystko zależy od tego, kiedy dojedzie pizza, bo będzie na Was czekała pizza na korytarzu. Na nas wszystkich też zjem kawałek. I tutaj jest woda, jeżeli ktoś jest spragniony, jak tylko skończę mówić, zanim się prelegenci ustawią z kolejną prelekcją, można śmiało sobie podejść i się poczęstować. No i przeskoczyłem. Tak czy inaczej, po przerwie około pół godziny Dominik będzie miał drugą prezentację i opowie nam o bytecodzie, o hakowaniu i pewnie wplecie jeszcze w międzyczasie ze 3 lightning talki w swoją prezentację. Jest to niewykluczone. I co do lightning talków, bo w prezentacji Dominika jest czas na lightning talki. 2 słowa wstępu, co to jest. Lightning talk to jest maks 5-minutowa prezentacja, w trakcie której każdy z Was może podejść tutaj, wziąć mikrofon, wyświetlić coś, pokazać coś, poprosić nas, żebyśmy weszli na jakąś stronę i ją wyświetlili i przez te 5 minut opowiedzieć nam na przykład o ciekawej technologii, którą ostatnio poznał, o innym evencie, który się odbywa w okolicy. To jest czas dla Was, żeby podzielić się wiedzą. Czy wstępnie jest tutaj ktoś, kto byłby zainteresowany przeprowadzeniem lightning talka? Mamy 2 osoby. Dobra, 3. Tak czy inaczej, bardzo często w trakcie tych spotkań lightning talki pojawiają się w trakcie, bo ktoś się czuje zainspirowany i sobie przypomina, a w sumie to mógłbym jeszcze o czymś opowiedzieć, więc będę powtarzał to pytanie i w dowolnym momencie można mnie łapać i się zgłosić, że chciałoby się lightning talka przeprowadzić. Będzie też dzisiaj konkurs i konkurs polega na tym, dzięki uprzejmości JetBrains mamy do rozdania 2 licencje na PyJail Professional. Na naszym Discordzie powstał kanał Pykonik 70, na który za chwilę wrzucimy ogłoszenia. Podzielcie się na tym kanale czymś ciekawym, czego się nauczyliście. Posty 2 z największą ilością reakcji na koniec spotkania dostają licencję PyJail. Więc jest to sposób, żeby i podzielić się wiedzą i przy okazji, jeżeli ktoś potrzebuje licencji, będzie mógł ją w łatwy sposób dostać. To jest tyle, jeżeli chodzi o agendę. Teraz kilka słów i podziękowań. A nie, przepraszam, zapomniałem o jednym punkcie. Czy ktoś jest chętny, żeby potem się udać na afterparty do infuzji? To ręka w górę. Jest całkiem nieźle. Zauważyłem taką tendencję, że im więcej razy zadaję to pytanie, tym więcej osób ostatecznie idzie na afterparty, więc spodziewajcie się usłyszeć je jeszcze dzisiaj ze 3 razy. Infuzja jest dosłownie zaraz za rogiem. Nie mamy tam rezerwacji, ale zawsze znajduje się dla nas miejsce i można sobie kontynuować tam rozmowy z innymi osobami, często też z prelegentami. Jest to fajna okazja, żeby się powymieniać doświadczeniami i wiedzą. Teraz już wszystko. Kilka słów o sponsorach. Pierwszym sponsorem dzisiejszego spotkania, dzięki któremu czekają na Was przekąski, czyli pizza i napoje, jest Watix, o którym sam opowiem akurat, bo należy do tej firmy. Zazwyczaj mówi ktoś inny, ale tym razem to będę ja. Watix jest dość ciekawym startupem, którego development odbywa się w Krakowie. Jest ciekawy o tyle, że jest to firma, w której na początku najpierw pojawił się klient, a dopiero potem właściwie powstał produkt pod tego klienta, więc nie jest to startup, gdzie ktoś sobie coś wymyślił i zobaczył, czy to się sprawdzi, tylko od samego początku ten rozwój jest bardzo blisko klientów i firma ta działa w obszarze Environment, Health and Safety, czyli głównie zarządza bezpieczeństwem pracowników, którzy pracują w odosobnieniu. Można powiedzieć, że pracując w tej firmie jest szansa, że kiedyś komuś się uratuje życie, co jest w sumie fajne. No i co? I Watix szuka w Krakowie senior backend developera w tym momencie. Jeżeli ktoś byłby zainteresowany, to można mnie też łapać. Mogę opowiedzieć trochę więcej o firmie już później, albo też na afterparty. I nie będę więcej przedłużał. Jak ktoś jest zainteresowany, to niech mnie łapie. Drugim sponsorem dzisiejszego spotkania jest JetBrains, o których też również opowiem. JetBrains oczywiście są twórcami m.in. PyJail i dzięki nim mamy konkurs, w trakcie którego zostaną dzisiaj rozlosowane licencje. 2 słowa o partnerach. Naszym partnerem jest Kosmo Politechnika, dzięki którym mamy tą super przestrzeń, gdzie możemy Was dzisiaj wszystkich gościć. No i bardzo się cieszymy, że mamy tą przestrzeń. że jest to przestrzeń na uczelni dodatkowo. Wydaje mi się, że to jest bardzo miła odmiana dla Pykonika i jeszcze dojdziemy do tego, żeby tą przestrzeń wypełnić w całości, tak żeby nie było gdzie usiąść, żeby ludzie musieli siadać na stolikach. Widzę, że powoli do tego dążymy nawet dzisiaj. Kolejnym partnerem jest Kluk, Kraków Linux User Group. Zazwyczaj mówię, że to są te osoby, przez których toniemy w kablach, ale dzisiaj zorganizowali się tak, że siedzą tam z tyłu. Są to osoby, dzięki którym mamy streaming, zaplecze techniczne, nagłośnienie. Oni sprawiają, że te spotkania wyglądają profesjonalnie, no i im za to musimy podziękować. I w sumie teraz możemy podziękować wszystkim sponsorom i partnerom brawami. Ostatnie jeszcze słowo w temacie partnerów. Pierwszą prelekcję warto odnośnie pierwszej prelekcji wspomnieć, że jest to dzięki uprzejmości firmy też Golem. Chłopaki opowiedzą trochę o sobie, ale są też rzeczy na stoliku, którymi można się częstować, z tego co wiem. Ale chyba o tym też powiecie. Chyba tak. Dobrze, ale wydaje mi się, że można się nimi częstować, jeżeli ktoś chce koszulkę albo inny swag. Koszulki za darmo. Można wziąć sobie koszulkę. Nie trzeba. Więc trzeba się spieszyć. Tak. Gdzieś przy okazji przeleciałem. Bo to nie ten przycisk, przepraszam. Ostatnie, co chcę powiedzieć, to tak jak wspomniałem, mamy konkurs na naszym Discordzie. Na Discord można dołączyć w dowolnym momencie, wchodząc na adres discord.pykonik.org. Jeżeli ktoś jeszcze nie jest na tym Discordzie, to zachęcamy. Jest tam trochę dyskusji około Pythonowych. Fajnie jest mieć dostęp do lokalnej społeczności. Zawsze można zadać jakieś pytanie, wymienić się informacjami, czy nawet po prostu umówić się z innymi ludźmi, jeżeli ma się na to ochotę. Z mojej strony na ten moment to jest tyle. Chciałem zapytać was, czy ktoś ma jakieś pytania co do przebiegu spotkania. No to jeśli nie, to teraz mamy 2 minuty przerwy. Jak ktoś potrzebuje się coś napić, to śmiało, a my powoli zmieniamy laptop. Dobra. Ty już lecisz?
Tu kabel? Tu kabel. To ten niżej, jakbyś mógł?
Masz mikrofon, dobra.
My sobie jeszcze będą prąd, wiesz? Tutaj się łączyłeś? Bo tu miałem prąd. Czekaj, bo tu miałem... Tu jest drugi, wiesz? To ładowarkę, tak, że... Czekaj, nie, właśnie. Jest zielona, chyba.
Dobra. Tutaj może nie być piękny podgląd, ale tu masz następny, poprzedni. To jest klawiatura po prostu emulowane. Ja tu masz podświetlenie, jakoś coś mógł pokazać.
Przemek, wiesz co, bo mamy też swój. No.
this will be in English, just that was the plan, and that's how we prepared, so yeah. Even though we could probably do it in Polish, we'll continue in English. So, here I am. My name is Przemysław Idzkiewicz, also known by the nickname of Blue Shade, or Blue for short, and I'm here with my colleague, Lucjan Dudek from Golem. We both work for Golem, and we currently are part of the team that's responsible for implementing Ray on Golem. So that's what our t-shirts say also. And yeah, we want to tell you first about Ray, which is an awesome piece of software, and then about Ray and Golem, which we also like to think that it's also an awesome piece of software too. So yeah, let's start. Yeah, so the plan is that first we will tell you about Ray and hopefully get you interested in Ray if you don't know already. Then we'll tell you about how Golem fits into the picture. And lastly, since we have just came out of the MVP and we think that our software is ready to be shown to the public, we will tell you about our beta program and application creator support program. So to start, how many of you know Ray or know what Ray is? Well, that's a few, so yeah, that's a good start. But maybe it's even better if not too many, because you will maybe learn something useful. So yeah. Ray is in general piece of software that allows you to parallelize Python code easily, and there are already quite many projects that already benefit from Ray or use Ray, integrate Ray in their libraries or in their backends. What it does, first of all, is it enables trivial parallelization of Python code, and it's already useful if you have a local machine with several CPU cores or several GPUs. You can use Ray to easily distribute code computations to that many resources that you have. But more importantly, without changing any of the code that you have, it allows you to trivially scale to clusters of remote machines that can be deployed on clouds, on AWS, Google Cloud, etc., also on Golem. And again, I think one of the best parts about Ray is that it's already quite a mature product. So it's already integrated with the tools you might know that work with Golem, like Pandas or Scikit. And it has also a couple of libraries built on top of it that are specifically aimed at machine learning and AI models. So yeah, and that's how the stack looks. So you have Ray, that's not, okay, that's gonna be hard. What? Oh, okay, that's gonna be easier, yeah. Yeah, that is easier. So yeah, you have the cloud, obviously at the bottom, which Ray connects to, and it has several backends implemented. And then on top, you have those libraries that I mentioned. So yeah, Ray has many ways that you can utilize it. So we're gonna show you like the most trivial way, and the most trivial example. Then we'll follow up with a bit more complicated one. So yeah, this is like a trivial piece of code. You have just a function, like here. Oh, no, not this one. You have a function that you want some computation, perform some computation, and for example, you want to execute it 1,000 times. So this is your code normally, and what it takes to put it through Ray is you add a decorator like Ray remote, which assigns this function, compiles this function so it works as a Ray on a Ray worker, and then you with this dot remote call, with a remote method, it creates like a future object that is automatically scheduled on array, and which you later pull reference. The object IDs are references, and array get pulls all the results of those computations for you, and you finally get results as normal, whatever the function return. So this is like what it takes to use array. As you can see, it's pretty easy. And then there is, I will show you a slightly more involved example, not much involved, but from this, if you want, for example, if you're interested in finding like a collision and a hash collision or like something like this, where you scan like a large array, but you're interested in just a couple of results or just some criteria that your results must match, you can use array weight, and it will return the first or as many returns as you want, and you can decide whether you want to continue with it or not. So that's the most basic usage for array. And yeah, now I will show you what we have prepared as an example. So our example uses Stable Diffusion library. Like it's not the newest version, so maybe it's not impressive as it is, but it's an interesting use case for array. And what do we have here? This is a slightly different usage because we have a class here, not a function. And with this decorator, we define this class as an actor, so like a worker in array's parlance. I mean, it's actor in array, but it's basically a worker. It's designed this way because classes keep their state, so we don't have to, like, for example, load the model, because the first thing it does in the init, it loads the model and initializes it, which takes quite a bit of time, even on a modern CPU, and so we don't want to repeat it multiple times. And then it has the method render image, which just uses the already initialized model on the worker to use your prompt that you give to render the image. So this doesn't work like this. And again, what it does is we check how many GPUs we have on the machine, and spawn as many actors as we have GPUs, and then with those we just loop as many times as we want images, and we find available renderer. We call render image remote on this actor, and we then wait for results. Once we get the result, once we get the result, we save it on the host machine. So maybe I should have told you about how array is constructed. It has a head node which controls the whole cluster, and then it has multiple workers that perform the computations themselves. So it saves the image on the head node. And so this is the end of part one. And then I'll pass my voice to Lucjan, who will tell you about Golem and how Golem fits into the picture, and we'll show you how our code works.
Okay, thank you. Can you hear me well? Okay. Okay, so that concludes the first part. And so if you want to run this program, you need to have some infrastructure underneath. So that's bringing us to the Golem. And the first question is, how many of you actually heard about Golem? Wow, okay, we have 2 people, okay. Okay, so you might recognize this hashtag. It stands for the Decentralized Physical Infrastructure Network. And Golem is just that, is the marketplace built on the peer-to-peer network where peers can exchange computing power. And it has a few characteristics that are important in this context. So first of all, it's open source, and it's so the Golem protocol is open, and Golem as a company is providing daemons that are able to communicate in this network. Yeah. And there are no Golem fees, so Golem doesn't add extra cost to that. Everything is transferred directly between peers, so it's only like the payments are on the blockchain, so the only additional are due to the usage of blockchain. Yeah. And as for now, we officially only support CPU sharing, and GPU is in the beta test. And as you saw with example that Blue showed you, our code requires several diffusion, so we will be using that for our showcase today. And we are open to everybody, so everybody can come in and join the network and connect to the network and use our daemons. So that data privacy and the reliability are the factors that has to be taken into consideration when interacting with Golem. And related, I mean, in terms of reliability, we are similar to the. I mean, as for now, from our tests, it's similar to the Amazon Spot instances. So it's not bad in any means. Okay, so if we look again at this chart, Golem, we can locate Golem on the bottom and as an alternative to the clouds. So you can have like cloud or self-hosted machines as a backend for the Ray, and Golem is an alternative for that. So you can use this infrastructure to run a Ray application on. And with Ray on Golem, I mean, the way the Ray is using those clouds to run a cluster is via abstraction called cluster provider. So each cloud has its own, like AWS or like self-hosted machines. You need like specific program that will allow you to, will enable you to use this infrastructure. And Ray on Golem is just that, a cluster provider for Ray, which allows to use Golem infrastructure as a Ray cluster, as a Ray infrastructure. And we strive for the easy setup. So there are only 4 steps required to run this. So first step is to install the package. Second one, first one is to install the package from the repository. Second one is to get the configuration file. And we have a few example configuration files that are ready to use. So once you get the file, you don't have to change it in any ways. You can just use it. The third step is to run the Ray app command with this configuration. It will start the cluster. And then the last one is to submit, so like run your code on the cluster and your Ray application. And only those 4 steps are required. And this will run the application on testnet, which I will tell you a little bit in a moment. And from that point, the Ray autoscaler will handle everything. So we'll manage cluster, we'll add nodes if this is necessary. So if your application requires more computing, the Ray will discover that and will try to add more machines to the cluster. Of course, this is according to how you create your Ray application, and you can also adjust the configuration so it doesn't scale automatically. You can scale it manually, but for this example here, it's set up in a way that automatically. And that brings us to the second part, in which I want to just show you how easy it is. Oops. Okay, so I already have a package installed. So Ray on Golem version gives me version 0.10.0, which is our MVP version released a few weeks ago. And so I already has this installed, and I have my configuration file, which is tailored. So we will use the GPUs instead of standard testnet CPUs. So I will just run the Ray app command. Okay, so Ray app, our configuration, yes. And this will start looking for the machine that fits our configuration. And for those, we are looking for GPUs that will handle our example that Blue showed you before. And we are getting an agreement. So while this is happening, we can talk a little bit about our next topic. I don't know if this is well visible or not, this presentation. I hope you can see something. So it's natural to compare a little bit to the other clouds, I mean to the cloud providers, because Golem is not really a cloud provider. So first of all, there is no sign up, no account creation. You don't need to provide any personal information. You don't need to provide any payment information. And there is no like extensive developer console that you can be you can have hard time interacting with. Everything is handled in the configuration file. Second thing is that we provide a free-to-use testnet. It consists of the single CPU micro machines that are enough to test something, but not enough to actually compare to like local machine on actual machine that you would like to use. So this is completely free and everybody can use it without, as I said, any account creation or anything. Next step is that we provide tools that help people switch to the mainnet. So on the testnet, everything is free. On the mainnet, you need to somehow pay the peers because it's like open network. Golem doesn't actually have like public machines on the mainnet, and this is all community. So if you want to like use those machines, you have to pay for them. And Golem is trying to create tools to make it as easy as possible. And so overall, we strive for effortless cluster management. So we already had the cluster running. It was quite fast. We can check how well we did and how much we have. So let's look at the status. So we have array execute with our cluster, array status, and it will show us how many machines we have. First machine is the head node, which is used for computation and for scheduling. And we got 4. So and for this configuration, so we can save time, we set up in the way that we will start 3 workers right away. So you can see we have 1 head node and 3 workers that started after the head node started. So we have 4 GPUs to use. So we can run our example. So we have, and for that I need a prompt for the stable diffusion. I have something here, but let's remove it. Okay, so we have submit our application. Let's go for the 10 images, but I need a prompt for you. So I need some random words for the stable diffusion. Somebody want to see something from the AI?
So anybody has anything intelligent to say to stable diffusion model?
There is a hidden gift for the person who.
Yeah, there is.
Who?
Python on the horse. So yeah, just one. Pretty nice container for like drinks. I use it every day. It's really nice.
I scheduled it, so it's already working for us. So now the head node will schedule all the tasks, and we can see here. I hope it doesn't go too fast. We have 4 GPUs. Oh, yeah, it go away. Yeah, it went. Yeah, it said that we have 4 GPUs. Let me. Here. We have 4 GPUs, and we are rendering 10 images. So the head node will schedule them. So one by one, and once one task is finished, he will schedule another one. Then the first part of the init will load, or is already loaded on each of the worker, and after that only the execution will be scheduled. So the logs are all messed up because we have multiple machines. This is not perfect for the demo, but we are getting them. And Ray is shrinking those logs when he thinks they are very similar. So we can see that like very similar progress bars on multiple machines. So this is hard to see, but you can see that we get some results. We get the number 2, number 1, number 3, like index 0, those sources. And I think we're done, yeah. So it was fast. And yeah, we can download those results now. So, okay. So we can actually see them, I hope. Okay. And we have the Python on the horse. And it's not on the horse, but it's a Python. And this one is, did I spell horse that well, that bad, or? I guess, yeah, it's not, the horse is not recognizable, I guess. A single horse, please? Yeah, there is a, and it's not a Python. Okay, yeah, that's closer.
Wow, it worked.
That is nice. On the, there are only cowboys on the horse, I guess. Yep. This one is a Python. Yeah.
At least it looked like it had a tail or something.
And this one is also not on the horse. So the Python is strong, but on the horse not really. There used to be the horse, but not anymore. Okay. Let's come back to our presentation. Okay. So to wrap up this, if you are new to Ray, the things I would like you to remember is that the Ray offers a seamless extension of your machine. So for this laptop, I didn't have any GPUs, and I could use Ray to add GPUs, basically 4 GPUs to this machine and use them. It's also like if I would want to have like the CPU have your computing, I can firstly I can use for the Python. I can use all of them at once, and I can extend and add more with another machines. So this is what the Ray does, and you saw the code. It was very simple. It didn't require any like strict knowledge to actually do that. Other thing is that Ray will automatically add the nodes. You didn't see that actually because I mean it happened while I was speaking. That first there was one machine and then the 3 other was added, but it happened so I could schedule the work on the first machine and the other will show up during this, and if I had like tasks, it will be added on those run all those other machines. And third part is that it has libraries. Blue talked about it. We didn't really showcase any of them, but Ray, apart from these primitives, and that allows for like easy parallelization, also allow to interact with specific libraries like Hugging Face, or like it has like pandas and PyTorch integrations. And if you knew Ray already, so not many people here, but the things I want to highlight is that Golem can provide you with the machines. And it's like you don't need to perform too much configuration for it to work. So it's like simple, straightforward, and it's easy to start and get going. Yeah, and if you ever find yourself in a need of the Ray backend, you can consider also Golem because it might be the best for your case. And that concludes. What's happening? That concludes this part of the presentation. And if you would remember only 2 things for this presentation, we would like you to remember that the Ray is an amazing Python tool that is very useful, and that the Golem is a Ray backend that is worth considering. And we have 2 messages for you, the next steps. So we are looking for beta testers for the Ray on Golem. So if you like to try that out and be somehow reworked by us, so we are open to that. And you can find this on the Ray on Golem network, I think. There is a form you can apply for. And we are also looking for the app creators, because we would like to see the Ray apps run on Golem in the real world. So if you have any idea that Ray might be a good tool for, you can also contact us and we can collaborate and we can help you bring those ideas to life. Yeah.
So just to strengthen this last bit, if you have any computation heavy applications like machine learning, or maybe you have like weather models or other models that you think might benefit from computations, either CPU or GPU, and you may think that it would benefit from like a cloud distribution, but you don't have resources yourself, you're welcome to talk to us, and we can arrange for you to be included and to be supported on our network, so we can run this on our mainnet and see whether it helps your application.
Yeah. And then we will be available today here and during the break and in after party, so you can talk to us there. or you can find us on our Discord at Golem, basically. Yeah. Thank you for listening, and I think we have some time for questions.
Hello. Does this parallelization here avoids the global interpreter lock in Python, or
yes,
how?
it's separate processes. It doesn't run in a single Python process.
Okay. And the second question is, how much money can I make by sharing my GPU?
So it's okay. I don't know exact numbers here, so it's hard to say really.
Okay.
I mean, we are in beta test regarding GPUs, so yeah, it's hard to say.
It's best if you just joined. I don't remember the address now, but if you go to our Discord, there is a channel for GPU providers, and you can just join the program and see how much you make. It's currently in beta test, so mostly it's our I think our test framework that's running computations on it, but you can already join it and see.
Okay.
Yeah,
We
as
also
Lucjan
have
said, it's still in beta test.
Yeah. We also have like different product that is like focusing on that. We have like it's called like we have partnership with GamerHash, which is like aiming for people to share their machines, share their GPUs where they are not using them. So it's also like we have something, but I don't know how to join that.
I think the same way. Actually,
Yeah,
it's
it might
all
be
the same
connected.
provider, I think.
Yeah.
But it's
Yeah.
but
Yeah,
it doesn't work with
it's-
Ray though.
Yes,
The,
it
the
doesn't-
basic idea is I don't have a problem with sharing my GPU as long as the electricity is paid, basically. Yeah. So.
I mean that's the same rule.
Yeah. Okay. Thank you.
Okay.
Any other questions?
One here.
There are rewards for questions. I mean, we have just a couple of those
There.
containers, but we decided to give them for some effort. So there you go.
So in that case, I have two questions. The first one is, are you able to set some requirements for the machines that will run your code?
Yes.
Say that I need a huge amount of, a given amount of RAM or VRAM to run.
Yes, it all can be set up in those configurations. There are like no limits, so you're like picking every machine basically, but you can narrow it down. I think I can show a little bit about that maybe. So if we look like at the configuration, where is the other one? So here, for example, I have example where I have where is this at the bottom? So I have like worker should be like of minimum 4 CPU threads and a maximum of 50. Here, right? And if I leave it blank, it will just take everybody. And this way you can narrow down what machines you get from the network. And like one interesting thing is that on the network we have providers which have like 32 CPUs. So there's like big machines. I think there's also one that is like 64 or something like that. So like a huge computer with like many cores. So like if you want to have like single computer with many cores, you can also find that. So you can go like wide with multiple machines or single one with like big one.
Okay, thank you. And the second question is, if I want to be a hardware provider, do I have to ensure the security of my computer, or do you do something to make sure that should I have a computer just for running tasks to make sure that I am secure, or are you doing something to somehow separate those processes?
Someone can have access to your computer while you are renting it, right?
Yes.
Blue, can you help me with that?
Yeah, I think I can answer this. So it's different for GPUs and CPUs, currently at least, because I'll start with the GPUs. With the GPUs, we have like a limited runtime that doesn't it's not as permissive as the regular runtime. We limit the outbound network and some other things so that you won't destroy someone's GPU, but it works like that you have to commit the whole machine just for the provider, because it just takes over this GPU and doesn't allow you to use it for a regular system. So that's different. With regular like CPU runtimes, you just start the daemon, the Yagna daemon, and it spawns the runtimes whenever they are needed, and it uses a QM virtualization, and it creates its own containers. So the containers are limited. As far as I know, you don't have any ability to break out of them. The only thing is that you have limited access to outbound networks, so your computer can be used, maybe not maliciously currently, because we don't allow random network into a random outbound access, but it can access the internet, and people can upload their stuff. So there are some like maybe soft considerations that you don't have full control over your machine, but still it's not possible to break out of the container as far as we know. It's different the other way around, because as a requester you don't have guarantee that someone will not like steal your content, for example, because it's not it resides on users' hard drives, so people can access the files. Yeah, that's it.
Okay, thank you.
Question, Doug?
Do you have any metrics? How big is the current network, and what's the power of the network?
We have a website, which I don't know if I will be able to access now. Yeah. It's the Golem stats. Stats Golem. So we have a website for that that should showcase that. So we should see what is right now. Do you remember what exactly? Yeah. So maybe that would take some time, but there is a site, and I know where we can click somewhere to see some general stats. Oh, there is it. So network earnings, and we have number of providers. There is 2,050, almost 2,500 providers right now, and which is like 15,000 cores, CPU cores available. Storage capacity and total memory in terabytes and terabytes. So this is the current state of the network. I mean, briefly. It's not because it's peer-to-peer, so we don't know exactly everything. It's like from observing.
Okay, thanks.
And we had one question there on the.
There are multiple data pipelines, data processing tools, for example, Luigi, Airflow, and many others. Why exactly Ray? Is it something special about Ray, or like it's better fit for Golem? Like why you choose Ray over any other data processing tools?
It's a hard question, actually.
Yeah, I would say that it's just first such generic integration that we did, because earlier we started with like plain runtime, and we offered examples built with just either pure JavaScript or pure Python, and we just showed how to start containers on Golem and just run random code on it. And then we decided that there are better tools like Ray, which has already built infrastructure, and Golem is just a backend to Ray, so we benefit from the whole ecosystem that's already built on Ray. But for now, we don't have like the best answer. We didn't choose Ray because it's the best. It's just pretty popular in the ML world and AI world, and with a lot of people interested in AI, we wanted to try to answer their needs, and just that's the most basic question. But we will be working on other integrations and other ways to run to help Golem fit
bring
into the
bring
ecosystem.
Golem to people actually.
Yeah.
It has like so the primitives of Ray seem like simple enough, and we had this struggle that our SDK was not simple enough, and it was like complicated. And Ray brings this layer that is simple enough and so we both can benefit in a way.
Yeah.
We have one question here, so maybe Blue, you can pass the.
Yeah, I can pass the microphone.
I'm wondering if Golem or Ray have some analysis of the computation process. I mean, did some introspection into the process, because you don't know how long it can take. Any prediction how long my, for example, computer will be busy for some other stuff? Thanks.
I didn't check this myself, but the Ray creators claim that they are statically analyzing the code, and the decorator is analyzing the function, and based on that, it like checks how much it will take. But this is what they say, and they are optimizing for it. So if you have the same operation, I mean, according to Ray creators. So I don't know if that's actually true, but this is what they say.
So if there is some analyzing of static analyzing of code, I cannot be sure that my code, for example, if it's some infrastructure that I'm working on and not going to share it, I cannot be sure that nobody else will know what I'm working on. Yep, am I right?
Sorry,
Is your question about not sharing your data as a requester?
Yes.
So Golem, as Lucjan said earlier, this is like a feature of Golem currently that it doesn't guarantee data security. So if your data is crucial for you and you don't want to share it on the network, probably Golem is not the best solution for you. We have one solution, like a partial solution to this. We want to introduce a concept of like a certificates for both providers and requesters, where you can be sure that you're running your code on providers that you, for example, have a pre-agreement with, or that have been KYC, passed the KYC process, so Golem or any other party knows who they are. But that's it. It's a peer-to-peer network, so for now at least, doesn't have any guarantee of privacy.
And there is no like account creation and all the stuff, so everybody is anonymous by default. So only if they like present themselves via the certificate, then you will know who you're working with, right? So if you want to bring that data privacy part, you will need that. So you need to pick like from the subset from the network.
I have one more question from Mike.
Unfortunately, I'm out of the containers, so.
That's fine. That's totally fine. I have a question. You mentioned about the security, more or less one side, so that it's hard to harm the computer with the script. But I wonder, how does Golem save your script from the malicious attack from the device it's running on? I know, like changing the. For example, the first thing I can think of, like replacing PyPI with some custom malicious repository and trying to use some libraries that would affect your data.
Okay, so in terms of the internet access, that you cannot really do that because there is limited, like the outbound is limited in a way that we have like the Golem repository that we have the packages then. So like so there is possible to open yourself, so you can use the requester that is open to everything in the internet, and then it can do that. But like by default, it doesn't do that.
But I think was the question more about generally influencing your computations in a malicious way?
Yes.
So
it can do that.
Yeah, they can do this. Just we didn't see such behavior so far, but yeah, it's certainly possible.
Yes.
So
yeah, we have like that. Trust
there
reputation system in the network, which like when you're picking the providers, it goes by reputation, and then providers who are not performing well are like automatically like less likely to be picked. And then we are working on that, and we hope to like bring the fraud control there into that system.
Yeah, that's part of it, and the other one that we had I would say not even brief, but maybe longer research into running on secure enclaves, and so far it's not feasible to run Golem on secure enclaves. But yeah, that's one possible answer. Although, as far as I remember, Intel has stopped producing processors with the secure enclaves. So I don't know what the future is here anyway.
Okay, thanks. Okay.
So a quick non-tech question. You said you're not taking any fees for either providing or using resources. So how do you generate money?
We don't generate money. Golem is a crowdfunding project which it just have vision to fulfill, and the vision is to create a Golem, a network. So the network to exist, and this is only the goal of the company. So the money was gathered, and it's like so far it's enough, and we don't need to make money actually to make this vision come true. So
yes. We ran the GLM. There was a crowdfunding for GLM token. It was called GNT in the beginning, so Golem Network token, and the crowdfunding allows Golem to function so far. So yeah, that's it.
Yeah. So like
the idea for the network is to be self-governing or self-sustaining. So that's why Golem itself doesn't interfere into the network.
So the idea is that when the Golem runs out of these funds, it will be the place that they will be self-sustaining, and the Golem company will no longer be needed, basically. So like the Golem company stop exist, and the network will exist by itself. So that's the end vision.
Okay, and the future developers of the repository will be non-profit?
I mean, it's open source, and we are. I mean, at this point, we hope that it will be like taken by community.
But there are a lot of actions that Golem, both Golem Factory, and there is actually another part of the original team, which is Golem Foundation, which take care of both the GLM token and securing some funds for future functioning. So it's there are ways to benefit for Golem Factory. It's just not Golem Network itself.
Okay, thank you.
All right, that was a lot of questions.
Okay. So thank you again.
Thank you.
Thank you.
So now we will start a 30 minutes break, but the pizza is not here yet, so probably it will be here any minute. So for now, please just enjoy some drinks. Oh, that's them calling. Okay, so the pizza will be here in like a few minutes. Teraz tak, chciałem zapytać, czy ktoś nowy, kto nie zgłaszał się wcześniej, chciałby poprowadzić Lightning Talka? Na razie nic, ale jakby co, to zachęcam, że po prezentacji Dominika będzie przestrzeń na zgłoszenie Lightning Talków. Na razie wiem, że mamy 2. Jakby ktoś z Was chciał opowiedzieć o czymś ciekawym, zgłaszajcie się śmiało i nawet w ostatniej chwili możecie do mnie podejść i powiedzieć: hej, chcę 5 minut dla siebie, chcę opowiedzieć wszystkim o czymś ciekawym. A drugie pytanie, kto tutaj wybiera się na afterparty do infuzji? Troszkę więcej, ale jeszcze zadam to pytanie z raz, 2 razy, myślę, że będzie lepiej. Przynajmniej połowa 2/3 dzisiejszych prelegentów będzie na spotkaniu w infuzji, więc jakbyście mieli jakieś pytania o Ray, o Golemie, będzie taka okazja. To tyle na razie z mojej strony. Przypominam o trwającym konkursie na Discordzie i oddaję głos Dominikowi. Powitajmy go gorącymi brawami.
Hey, does this work? Test. Okay, so hey, I'm disconnected and I'm going to speak about Python specialized bytecode or hacking PyJail, because that's the name of the challenge that we'll talk about. But before that, a few words about me. If you don't know me, I have a blog on the internet. I'm also playing cybersecurity competitions in Just Cut the Fish team. I'm also a staff security engineer at a company called Trailbits. And I'm also maintaining a project called PwnDebug, which is written in Python, by the way, but that's a plugin for GDB, which is a native debugger. But we won't use that today. Anyway, let's maybe start with some simple things. There is this thing called Python jails or sandboxes that's in there. And the idea is that you may want to allow other users or users of your app to remotely execute code on your server. And the question is, why would you do that? I mean, there are certain use cases for that, but this is obviously dangerous. And by the way, this is also what I believe this Ray on Golem is doing. But but so the first question is why would you do that? Well, first of all, you may want to like implement an app that would allow others to like execute arbitrary mathematical expressions, because in Python you can calculate things very, very easily, and so that this may be nice. You may want also to like have some kind of like configuration language in Python for your app, because why not? I mean, there are some so cool Python literals out there that you can use for configuration stuff. And you may also have some kind of like arbitrary code execution where instead of like some configuration or just mathematical expressions, you may want to allow like any code, because maybe you want to develop some kind of competition where people create bots in Python or something like this. And people often like implement this kind of stuff by using the eval function in Python, which allows you to like execute code from a string, basically. And they sometimes do this kind of second argument where they pass in the dictionary with setting the built-ins to be empty. So if you do that, it basically blocks all built-ins like imports and so on. We can, by the way, look up it here. Yeah, so I hope this is visible, by the way. If it's not, I can. So yeah, with eval you can do something like print 1, blah blah blah, and this executes Python code. But if you do this like built-in stuff like this, so an empty dict for built-ins, there is a name error because there is no such a built-in like print inside of this evaluation. The problem is you don't really need like a built-in in order to execute Python code inside of eval. I mean arbitrary Python code, or to access built-ins, because well, the problem with it is obviously that someone can do something like import OS and then OS system and basically execute any code here, like echo or okay, it's invalid syntax because I think eval just takes one expression, but you could import something this way and yeah, you could execute arbitrary code like this. But you can access those built-ins in a different way. You can basically take this like tuple object and then use dunder class, dunder base, dunder subclasses, instantiate it, and this returns you the subclasses of the tuple object or type, and then you iterate over it, and then you find an object that's called catch warnings. You take some kind of index out of it, instantiate it, take underscore module, and dunder built-ins. And this way, I hope I have it somewhere here. It's called evalx. So if I take this string that is being saved in here, if I put it inside of this brackets like here, and I do eval with this sandboxing stuff, I will again execute the system function from the OS module. Because from this built-ins I took the import, and then I take import the OS module and so on. So obviously this is not great, and obviously if you want to execute arbitrary Python code or allow arbitrary Python code execution, you need to isolate or sandbox the environment. If you don't do that, that's very dangerous because someone can just steal stuff from your machine or change things. And in order to block this kind of stuff, some people implemented some solutions based on block lists. So for example, they blocked some Python bytecode opcodes, like calling a function or loading a global, or maybe they parsed the Python code into AST and then used a node visitor to go through all of the AST nodes and maybe block imports or block some load globals or something like this. But obviously, block lists can be bypassed, and I had cases even in real life that unfortunately I cannot really show, where I was able to hack lots of servers by bypassing a block list that was created in a similar fashion. Yeah, but since I said something about bytecode or opcodes, let's see what this is exactly in Python. So when you have a function like this in Python where you add two numbers, you can use the this module, which is a disassembler module in a built-in module in Python, for getting the bytecode or the underlying instructions of the Python virtual machine using this function. And here you can see that, like in the first column, it shows the line number of a given for the instructions that correspond to a given number. So for example, for this first number, def_foo, the resume instruction is there. And then for the second line, return x plus y, there are like 4 different instructions. And by the way, this bytecode is like under the hood. Each instruction is just 2 bytes. And what is also nice, there is this godball.org website, which you can use for example, defining whatever you want, like, I don't know, import OS or something. And you can, implement some code here, and it will show you how this disassembles. Now, this is a bit longer than we had in a previous example, because also the first line here is basically the code that we can see here. And this is the code of the script itself that defines the function. So the definition of the function is also like a code that needs to be executed. So here we load a const, which is a code object for this function. Then we make a function, then we store it in a name called square, and then we return const none because we did not execute anything inside of the main module. And then there's also disassembles the code object here that was a constant of this whole module. And we can see this resume instruction, which honestly it does nothing. But then you can see the 4 different instructions for importing something. So in order to import something, we need to load 2 constants, we need to import a name, and then we store the same name under the same name in here. This is probably because we could do something like import OS as XXX, and then the other name would be used here for this storing of the name itself. So an imported module needs to be stored in a variable in the end. And this is the last 4 instructions are for the return instruction here. So we are loading some variable num that was an argument here, and then we use a binary operator instruction to add 2 numbers, and then we return the result. By the way, since I said that each instruction is just 2 bytes, and honestly, 1 byte is for the opcode or the instruction mnemonic, which means this is the load fast is like a number under the hood, which corresponds to the load fast instruction. But the second byte in an instruction is the argument, and 1 byte can store only 256 values. Does this mean that if I have an instruction like load fast, and I want to load a variable, this variable under the hood needs to be put here as an index into some kind of list of variables? And since this is just 1 byte, does this mean that I can only have 256 variables? Well, we can actually see this here. I have a function here that is like def_foo that maybe I can show you here in the console. Can I? I can't. Did I copy this? Yeah, so this is the code. Here are I think 300 variables or something. It's like A equals capital A equals AA, blah, blah, blah. And at the end is equal 1. So if we do code like this and look at the very, very end of this, bytecode for this line, we can see that, here we are storing just storing something. I'm not sure what the copy instruction does, but basically we are storing, the copy is just copying I guess the value 1 or something that was there. But anyway, if we go further, we can see here that some of those, instead of just being 2 instructions, ended up being 3 instructions. So there's this extended argument opcode, like a special instruction, when the argument that you need for a given instruction needs to be bigger. So the virtual machine needs to kind of handle this, and when it executes the extended arg, it takes this value 1, and then here probably the underlying value is not really, in the bytecode, it's not really 287, but some smaller one, but this one above is saying that it's 255 plus this number here under the hood. Yeah, and I guess you can probably go further and further with that. But yeah, So I also said that there is like a virtual machine in Python because, well, the Python interpreter is a virtual machine under the hood. It's a stack-based virtual machine. I'm not going to really explain what this means, but under the hood there is some C code in Python. I mean, for the Python interpreter, and it looks more or less like this. There is this eval frame default function that is being executed in order to like execute, for example, a function in Python. And you know, they have those two variables, opcode and op-arg for the argument for a given opcode. They fetch it somewhere there. I'm not showing you how they fetch it, but at the end they have this like switch. So there is like a switch for a given opcode, and in previous versions they had like target and a given opcode and implementation of an opcode. Now they have an include for generated cases. And by the way, everything that I'm saying here is for Python 3.12. The specifics of bytecode, for example, is very implementation defined. So for a given Python version, this may change. And actually, like in the past, in like, I don't know, Python 3.4 or something, the bytecode was not 2 bytes long, but it was, I think, bigger. I don't really remember, maybe 4 bytes, but it was definitely bigger. Anyway, so they have this include here, and then they have dispatch. This is a macro that basically jumps back into a next opcode, or jumps to next opcode to be executed. So this is like a loop, but this is not really a loop because they use a goto in C language, which jumps into some line of code, kind of. Yeah, but there's this include, which includes another file here, and this file looks more or less like this. Obviously, this is just a part of it. So for example, there's this target for a NOP instruction. NOP means no operations, no operation, and it does nothing. So there is an instruction like that in CPython. I have no idea where it's actually used. I don't think it's ever generated, but maybe. There's this resume instruction, which does some weird C code. We won't really analyze it. There are also different things, like, for example, load const or store fast. So you can also see here that, for example, this load const, it uses this get item, frame, something, fcode, and co-consts. So the thing with, well, functions in Python, if I define like the functions foo here, is that those functions, can I do this? Yeah, so I have this function foo. I can do something like code. There is a code object, and you know, I can look up the constants that are there in this function, or I can look up the names or var names, and you know, those are the var names that are there. So those are like attributes of a given code object for this given function, and all of this is accessed in this C code under the hood. Yeah, and there are lots and lots of opcodes. Well, up to 256 because there is 1 byte for the opcode, right? And there are a few ways to find them out. There is this include opcode h file in CPython code. There is lib opcode py, which is used to generate the opcode.h file. And there is this module that also has all the opcodes in there. So here's an example of this opcode.h. So actually it's very, very long because there are lots and lots of opcodes. You can see some of them here. And obviously you don't see really those on the right, but yeah. There's this lib opcode py, which is a bit better because if you look on the right side, well, there is some Python code here, but they have some comments that describe, for example, what the argument of a given opcode is doing. So for example, in like a store attr opcode that is here, the argument is an index in the names list in this code object, and so on. Yeah, and as I said, there's also this module that can be used. So like this and all, or what was that? All op map. Am I on wrong Python? Oh, I don't have this imported. Okay, so if you do this, you can see, well, the individual numbers for given bytecode instructions or opcodes. And here are all of them. Yeah, so in the title of my presentation, there was this case of specialized bytecode, because I have shown you some kind of bytecode, right? And the thing is that there is this PEP 659, which is specializing adaptive interpreter made by Mark Shannon. The status of it is draft, but the practice is that it's already, some of it is already implemented in Python 3.11 and 3.12. There was some nice description of it in like the what's new for the Python 3.11. So, you know, this PEP is one of the key parts of the faster CPython project. So they wanted to make CPython or Python faster. And at runtime, Python is basically looking for some patterns, how the code is executed, how functions are executed, and it will replace some of the operations with different operations, with like specialized ones. And they also say that they will only specialize when they see that code is hot, which means it's executed lots of times. And also, they will despecialize code when they will detect that the specialization is wrong. I mean, wrong because you maybe used different types of arguments. Yeah, so let's see this in practice. So first of all, in Python 3.11, they added those two arguments for the this module, adaptive and show caches. So that's what we'll use always now, from now on, to see more of stuff here. So for example, for this addition function, we have load fast and load fast for loading the two variables, binary op. There's some cache instruction included here. This is because we use show caches 1, and then there is the return value. If we execute this function like 1,000 times with like some arguments that are numbers, and we disassemble it again, its bytecode has changed. Now, well, it starts with resume quick, whatever that means. And then there is like load fast, like, faster. This is like a specialized operator to load variables faster. We'll see that in a moment. Then there is again a load fast for y. This is a bit weird, right? Like, why do we need to do load fast kind of 3 times now? Well, we don't, which we'll see in a second. Then there is binary op at int, because we are adding 2 integers all the time. So, it detected that we always executed with integers. So well, why not just change the binary op with just binary op at int? And this is a faster version that, assumes that the arguments are integers, but it also checks if the arguments are really integers. And if they are not, it will despecialize the whole function. Or maybe just this instruction. I'm not really sure. And there's this cache which now has some counter, and if we execute this more and more, the counter will change. Yeah, so, I don't have it here, but we can go to this generated cases something, and find this load fast _ load fast. I will zoom it up for you. Come on. Oh, yeah, it's here. So what this instruction is now doing is it basically, it gets the local for the OP argument, and well, it's assigning it somewhere, but then it's also taking another OP argument from the next instruction that it will also, increment here. So it's taking another local variable, and it will then dispatch the whole, like get back to another next instruction. And in practice, because there is this increment here for the next instruction pointer, in practice, it jumps over the second load fast instruction that is there. So when we had this load fast for the y variable, since this load fast _ load fast already fetched the y variable, it jumps over this instruction. So this instruction load fast is just here because the index for the y variable is fetched from here. But one of these bytes is really not needed. But that's how it is. Yeah, so there are those optimizations here, and I can also show you that if we have x, y, return x plus 1. Oh, I want to comment this out. Can I? Yeah, I can. So and if I do foo 1, 2, and now import this foo, so caches 1, adaptive 1, we have this optimized code. But now if we add 2 strings instead, wait, oh, this function was not adding x plus y. Okay, so again, for in range, then this, and then we will now add 2 strings, and now disassemble it back again. We can see that well, it actually didn't really de-optimize it. Cool, but I guess if we execute it like maybe like 50 times, maybe it will optimize it to a different version. Oh, it didn't. The counter is 2. Yeah, the counter has changed. But yeah, if we execute it more, now since the counter probably fall down to 0, I guess it was changed to binary op at Unicode now. So it's all about the counter, I guess. But this has changed, as you can see, the specialization. Yeah, so now we will go to this PyJail returns. That's the name of the challenge from one of the competitions we have taken part in. This was Angstrom CTF. It was like a month ago, or 2 weeks ago. And we scored like the third place there, as you can see, as Jaska the Fish team. And this is how the challenge card looked like. So it had 23 solves, and there were like, I don't know, hundreds of teams that took part in this. They gave us the IP address and port to a server that we could connect to. And if we connected to the server, there was this Python script that was executed that we had to hack on. And after we hacked this challenge, we could steal what is called flag, so like a secret text that we have to provide for our organizers. Yeah, so here is Docker file for this challenge. It's not really interesting. The only interesting part here is that it uses Python 3.12 because we need to use the same version. And this is the code, the source code for the challenge. It's a bit messy, I would say, but it starts with taking some input from us. It takes code and one name, which is a string. Then it has some validation. This validation basically checks that the code needs to be maximum 20 bytes. Then the name of the length cannot be longer than 16 bytes, and there is some the length of the code needs to be divisible by 2 or something. And then there is some kind of for loop. Let's not really analyze what it really does, but under the hood, this is basically checking whether the opcodes by opcode bytes that we provided are not falling into the list of banned opcodes. And the list of banned opcodes is like this opcode.opmap.values. So we can see this here, if we do import opcode, what was this? opmap. So opmap is like a dictionary of opcodes. As you can see, this looks like most or a lot of opcodes. There's push something, there is swap, there should be some compare op here, copy, there should be some call, for example, and so on. And the values is just the numbers of those instructions or the opcodes itself. And then they do something weird. They create an empty function, and then they replace the code for this function with the code that we have provided. So they swap the bytecode of the function, and then they execute the function. So we can basically modify the bytecode of the f function and execute it. And what we have to do, we need to somehow be able to trigger arbitrary code to steal a file from disk from this server that the code runs on. Yeah, I have a demo here for it. Maybe here. Yeah, so I have this, maybe demo 1, I think. No. Yeah, this is the challenge. Yeah, this is the challenge. Yeah, so this is the same file, as you can see. If I execute it, now I need to provide some code. It needs to be provided in hexadecimal. It cannot be just 1 byte. It needs to be at least 2 bytes. And then I need to provide some name, but I didn't really pass in the validation that was there. Yeah, so there is some validation going on, and I failed on this. I can't count that high or something. Oh, actually, we can probably pass this one with BB00, I think. Yeah, but we ended up with unknown opcode 187 because the BB in hexadecimal corresponds to 187, and this is an unknown opcode. There's no opcode for this number. So first of all, since we have some list of banned opcodes here, how do we get the list of all opcodes that we can actually use? Well, we can take the band list, and then we can go over all the possible bytes for an opcode, and then we can disassemble it by creating like the bytecode. As I said, a given instruction has just 2 bytes, right? In practice, not necessarily, which we'll see in a second. So I have this get available opcodes code here, the same as we had on the slide. And I will execute it here, but I first need to enter here. And it's, yeah, get available opcodes. So what has happened is, this code was executed. And if the value that we had was not in the band list of opcodes, we basically created this opcode and disassembled it. So for example, for the number 6, there is this binary op add float. And by the way, initially there was this binary op, just binary op, right? And this is the specialized instruction for one of the options for the binary op. And if we disassemble it, even though we had just 2 bytes, this ended up being a code of 4 bytes because there is this cache instruction that was added on. So in the end, actually, some of those specialized bytecodes, they need this cache instruction afterwards because they use it, which I can show you in a second, later on maybe as well. But yeah, we can use some binary op specializations, as you can see. We have some call specializations, like call no keyword built-in fast, whatever that means. And they, those calls needs more cache bytes. There is like load add class that needs like a lot of cache instructions, and so on. There are some like load const, load fast that do not need any cache instructions. There are some unknown opcodes, which are those they will never. I mean, they do not work, do nothing if we try to use them. So those are the bytecode instructions that we can use. Second of all, we somehow need to be able to create code, like the code itself, right? In order to do something. So what we can do is we can import the this module. We can create some kind of class that will be our helper for getting like a bytecode instruction. And then we can have the bytes, instead of providing them from the keyboard, we can specify them in the following way. So here we, for example, have like a load global, then some cache instructions, because obviously there needs to be some cache instructions. And then we can maybe try to execute call. And by the way, those like load global or call are banned from the banned list because they are not the specialized versions. But I have made it so that the exits that were here are not really executed. So we can see if this works and does something. I think it won't, but maybe it does. I don't remember. So this is the demo. And yeah, oh, by the way, one more thing. Those are all the specialized bytecode instructions that we can use. What is also needed or helpful is basically displaying the resulting code. Because, well, if we want to construct a code and then it's placed in this function f code object, then maybe we want to display it, disassemble it again to see if it is really what we wanted it to be. So we have those like prints and like disassembling it or showing the code and then executing it. So if I do this here, we can see that this load global was like loading a now object and print, then having 4 cache instructions, then loading a global from the index 0. This index 0 corresponds, by the way, to the print statement, to the print name, because I have provided the name print, and this name is provided into the code object as co-names here. So this is how they updated the function. So the name that we provide is available in the function. And then we have like a call with cache. And if we try to execute it here, it's actually being executed. There's a segmentation fault because the bytecode was not great or not correct in the end. Like it didn't return from the function. But the print was executed. I mean, a print printed itself. So it was like as if we did print of print, because that's how we laid it out, the arguments in here. Yeah, so now the question is, how the hell do we hack it? First of all, we only can provide 20 bytes of bytecode. And as you can see, sometimes we need to provide, this is like 10 bytes already for just loading one global variable. And also, I didn't say it, but this is a load global, not specialized. A specialized version may be slightly different. But as you could see in like previously, as I showed you the how you can hack some kind of sandbox or Python jail with eval. That's more or less the things that you could maybe use. So like, you know, dunder import as a name. The problem is if you use like dunder import as a name and then .system, the system name is another name. And we can see it here if we do something like ipython3, import this, you know, def-foo. Or actually, I can show this on Godbolt. That would be faster. Yeah, so if I do something like os.system and then a call, so this is loading the name OS, and this is then, well, loading an attribute, but this is another name that needs to be in this code object. And we just have one name here. So another thing is maybe you could do something with globals or built-ins, but you still, if you would want to access something later on, then, well, like a name, then you can use it. An import with PDB would be interesting, but the thing is that in Python 3.7, they added a function called breakpoint. So this breakpoint function, under the hood, it does import PDB, which is Python debugger, and PDB set trace, which invokes the debugger. So maybe we can call the debugger through the breakpoint function. Yeah, also, as I said, certain opcodes have caches. This is something we have to consider because we only have those 20 bytes. And we need to find a way to execute breakpoint. So, well, how do you execute the breakpoint instruction? Well, you just take the global name, or you use load global built-in because that's a specialized opcode that we can use. And you then use the call py_exact_args. And well, this load global will load the breakpoint name that we'll provide to the function, right? And then we call py_exact_args. But will this work? Well, I'm not sure if I have it here, so I will copy this code from here. Maybe I have it. I don't, but let me do this, and I will just swap the code that we had there. So we are executing those instructions. By the way, previously I had here like 0, 0. The thing is that the opcode 6 is allowed, but since, you know, this is a specialized opcode and it needs caches, this will be treated like the cache. And the cache itself corresponds to some like index, module key version, built-in key version, whatever that is, but this is executed in the source code. If we try to execute it now, the execution under the hood didn't really trigger the breakpoint. So what happened, or how normally you would do an execution of a function with breakpoint? Well, if you do something like just breakpoint, and you know, disassemble this function, it will have, you know, a load global, then some pre-call, which I have no idea what this is, and then call. But it also has like a, you know, it's also like returning something. A function needs to return something. And this ended up being the problem here, that this function is not finished properly. And if we added here like I think like load const and return value, like, you know, by hacking it around with just yeah, load const 0, return value, and maybe 0, I guess. So we are doing something that we cannot do. Oh, sorry, it's return value, not return. This worked. We got the breakpoint. But the problem is, you know, the return value opcode or load const are blocked by the banned opcode list. And there is no specialized version for returning a value, because why would there be? So what we eventually did in this challenge to solve it is that we basically brute forced the last opcode that can be placed here, or the last few bytes that we can place here. And it ended up that if we do something like a load attr class, which, by the way, it needed so many like cache bytes, like 9 or 7 or something. And if we do that, this load attr class is something that is not banned by the banned list. And if we execute this, it's actually working. So now what happened? We didn't return from the function. But what we did is that we actually broke the function itself so that instead of, properly returning or something, there was an attribute error because we wanted to load an attribute. And some known type object or something didn't have a breakpoint attribute, but eventually the debugger was run. And since the debugger was run, we could then do something like import OS and then system and then cat flag txt, which was there on the server. I don't have such file here, but that's how you could solve the challenge in the end. So yeah, you could execute this breakpoint through some of those specialized bytecodes. So yeah, this is the solution. This is how it looked on the server. Sorry for the not great quality of the screenshot. So I had also a script that connected to the server itself. Then we got this attribute non-type object has no attribute breakpoint, and then we imported OS and then launched bash, because why would you use Python if you want to use shell? And then you can ls and cut the flag and get the information that sanitizing Python is so doomed. So that was this challenge. Oh yeah, by the way, certain opcodes have cached, and this is how you can find it out. So also the question is how to execute arbitrary Python code if you want to use it. If you want to do this. Well, obviously you should not, but maybe if you want to do is that there are certain ways to do it. Well, if you want to compute mathematical expressions, there are libraries for it. And the way they work is that they are doing some kind of evaluation of the opcodes or the AST of the nodes that is there, and only allowing a white list or allowed list of opcodes. And this is what this pownlib.util.safeeval expression is doing. Second, if you want just Python literals, there is this AST built-in module which has a literal eval for evaluating literals. And third of all, if you want to execute arbitrary code, please don't. But if you really need to, it needs to be isolated properly. So you should probably use something like nsjail or bubble wrap, or maybe a properly configured Docker container, maybe not the default one. But this can still be risky because, if you allow someone to, execute arbitrary code in a Docker container, they can maybe take all the RAM from your system. You can still limit it, so you can limit the resources, and this is nice. But they can still access lots of the Linux kernel things, I would say, and maybe they can exploit your kernel and escape things. So maybe you want to use VMs under the hood or something. Yeah, so by the way, this safe eval expr, it looks more or less like this. So if you would execute expression from a string, it would be computed. But then if you would try to do something bad, it will say that this opcode is not allowed. I haven't really tested if it works in Python 3.12. Maybe they missed the specialized bytecode instructions somehow, but I don't believe so, because you're specifying a string, so they need to parse it. You're not specifying the bytes itself. The AST literal eval, you can use it to instantiate string, bytes, numbers, tuples, lists, sets, or booleans, or even the non-object. So this is nice. And that was it for this presentation. So I'm going to take some questions, and I also have 3 lightning talks that I guess I would do afterwards. So thank you. So, any questions? There is a question on the left, far away.
Such optimizations, how much overhead Python add over the code? So basically, as far as you can see, in IPython, it was run instantly, and how much overhead we have on that?
So yeah, that's a good question. How much overhead we have? I'm not sure if we really have overhead, because they made it so to make Python faster, and they are benchmarking it extensively. And in this what's new in Python 3.11, they even have a table, specialized adaptive interpreter, that they looked up how much it speeds up given operations. So for example, I don't know, 10% speed up for binary operations, like 20% for calls or something like that, and so on and so forth. Maybe 2% it's not great for some things. They also said that at the very beginning of this post that Python 3.11 is between like 10 to 60% faster than Python 3.10. So because they actually made the bytecode longer by introducing those cache instructions and by specializing the bytecode and making those super operators like load fast underscore load fast, they made things faster in the end.
So when they replace like the basic opcodes by like
with specializations,
okay, they actually have faster execution time.
Yes.
In the end. Okay.
They sometimes end up not reading some of the bytes, as I showed you, like with this load fast underscore load fast, and then they are skipping the next instruction kind of, but just taking the argument of it. But yeah, it's faster. It's like a just-in-time compilation kind of, and they are only specializing if you execute some function lots of times. But this also means that if you execute lots of small functions, not so many times, those functions will be not faster. But if you think about it, since we have MyPy everywhere, almost everywhere, then maybe the MyPy annotations could be used to like think, oh, those two arguments are integers, so maybe we can specialize at the very beginning when we start like compiling to bytecode. But I have no idea if that's done anywhere right now.
And a side question, like, is it possible to implement jails or something like that using IST, like excluding some parts of IST type, like tree, and basically making some modifications there to make sure nothing is...
Sorry, wait, using NSJail?
No, using AST of the Python.
Oh, AST of the Python, but to like sandbox the code?
Basically manually parsing and excluding some statements which can be dangerous.
Well, if you are using a block list, then it's very likely that this can be somehow bypassed. If you are using something like allow list or a whitelist, then maybe it makes sense, depending on what opcodes you would allow. And this is what the safe eval expert is doing. If we would, I have a link here. Yeah, never mind, I'm not going to show the code now for it. Yeah. Any other questions or comments? If anyone has a question, we may be able to, anyone else, then maybe we may be able to pass the microphone faster, but yeah, go on.
Thanks for the presentation. It was crazy a little bit, but since you are specifying on hacking Python tools, maybe you can name for us some techniques or tools maybe that can help to make the Python code safer and not too easy to hack, maybe from your previous experience, something like that. Thanks.
Yeah, that's a good question. So first of all, there's this tool called Bandit Python. So this is like a static analyzer tool for Python code. It's not really great because it's only analyzing the code statically, and well, writing rules for it is not great, but it will tell you that, for example, YAML.load is not safe, which is not true anymore as far as I remember because the library was updated. But yeah, it detects some stuff. Second of all, there's this tool called SemGrep. This is a semantic grep tool for finding code patterns. So you can implement pretty much the same rules as with Bandit with it, but it's much, much easier to implement rules for it because you write the rules in something that looks like code instead of well, implementing the code in like Python or something. Do we have some examples? Can we show some examples? I have no idea. Yeah, I'm not going to probably show the, maybe? Okay, oh, Flask. Maybe this is a rule for Flask. So this is how you would write some kind of rules in SemGrep. There's some rule for use JSONify. I'm not sure if this is security related rule. But basically, it also can try to fix some stuff as well. Yeah. So this is another tool. A better tool is CodeQL. but I have no idea if it actually supports Python. Yeah, it supports Python. So this is a much more robust tool. It's from GitHub, but it's also paid. But if you have like GitHub Enterprise, you can use it on CI/CD. Yeah, and you can also implement your own rules. It's much better because it can also do some kind of like data flow analysis through like between different functions. I have no idea if it actually implements it for Python, but for other languages it does. Yeah. And
thank you.
Yeah, sure. Microphone. Maybe it works. So the question was, how long does it take for solving such a challenge? I don't remember how much did it. We actually solved it like in maybe 2 hours, maybe longer, maybe 4 hours or 5. I don't remember, honestly, because we were solving it in a hackerspace. Yeah, but a few hours for this challenge. Another questions? Okay, then if not, I guess I can go to, oh, there's another one, supposedly. But the microphone is dead, so we are using another microphone.
Okay, so maybe not really a question, but more of a comment. If you want to consider sandboxing Python, you may also consider using PyPy, which has a sandboxing mode, which splits the Python interpreter in 2 sides. One that executes the code and has no access to anything at all, besides standard input and standard output, and another part which gets those, let's say, requests for action, and then can whitelist and perform those or not, depending on your policy. Yeah, exactly. That's the page.
If it works, because it says it's like unmaintained, but there's some version in progress. But yeah, yeah. Where are my slides? Where are my slides? Here.
Okay, so just before you start the lightning talks part, I just wanted to check once again. Oh, maybe let's start with thanking you for the main presentation before you jump to lightning talks. And now I wanted to check who overall wants to give a lightning talk. Let's raise your hand. 1, 2, 3. Okay, we'll have 3 lightning talks, and we need to finish around 9:15. What? Around 10 minutes max.
Yeah. So hello again on my lightning talks now. My first lightning talk is about just CTF. So since I am playing CTFs and Just Cut the Fish, I'm also organizing them. And we are organizing 2 CTFs this year, actually. One will be in 15th of June, so this Saturday. Yep. At 10 a.m. our time, I believe, if I compute the time correctly. And we have some kind of licenses for IDA Pro as prizes, and also reimbursements for finals that are in Krakow, so maybe you don't need that. But you can also get lots of like CTF time points for this competition. We have for a few sponsors, and if you are interested, just go to the web page that you can see on the top of the screen. So feel invited. My second lightning talk is about zero-G flight. So who knows what zero-G flight is? Raise your hand. Okay, not like half of the room, probably. So I have taken a zero-G flight, which means I experience microgravity or zero gravity. And for this, I actually had to take a plane. There are like 3 companies in the world that can do that for you, and one is in Europe, the second one is like in USA, and another one is Russia, so I guess it's not really a viable option. But basically the one in Europe, they have like 5 different like dates for doing this a year, so it's not so easy to get on this. But if you do this, it's in Bordeaux, France, and basically the idea is that the plane is taking a parabolic flight, and it's doing like 16 of those parabolas. And when it's doing this parabola, so like flying up and then down in a proper angle, speed, and blah, 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 then you first start with some hypergravity when you are pulling up, which means for 20 seconds, you get like 1.8 G. So you are basically, you know, putting like the force is putting you into the ground. Then for 22 seconds, when there is this like parabola top or something, you are getting weightlessness. Well, depending on what kind of parabola the plane is doing, you may have like a Martian parabola, or like with Martian gravity, or like with moon gravity. We had like 2 moon gravities, 1 Martian parabola, and all the other ones were like 0 gravity. And then when the plane is pulling down again, well, then there is hypergravity again. Yeah, so, such a journey basically starts with some kind of lecture, because you need to understand, well, how this works and why they are doing it at the very beginning. So this company is actually like under some kind of like space agencies in Europe, and they are actually doing most of those flights for like scientific research to test stuff that will work on the orbit in the end. And you know, they have just 20 seconds of weightlessness to test things. And they are doing like 30 flights a year, of which like 5 or 6 of them are commercial. And the profit is going basically to scientific research. Then, well, you get your boarding, and you go through like a security check on the airport, obviously. And then you get into the airplane. And you know, there are seats in the back of the plane, but in the front of the plane, there is this space just for, well, doing the stuff. Wait, what the hell? This was something different. Yeah, so it starts with, you know, explaining some, like reiterating on the stuff that was on the lecture, like how you should act on stuff, because, well, you know, you start with hypergravity, then you have this weightlessness, and in this weightlessness, when it ends, you need to put your feet on the ground. If you don't do it, you will fall and you will hit terribly. So you have to be careful, and you can't really like swim or anything, because like, you know, doing this kind of stuff won't really change your angle or something. And by the way, this airplane has like 3 different pilots that are piloting it. Each pilot is actually steering a different angle of the airplane, because they need to, you know, put this kind of like parabola in like do it perfectly so that you can actually feel this weightlessness. Yeah, so this is what happens when there's hypergravity, at least at the very beginning, and you're looking at just one place, not really like, you know, running with your head, because if you would do that, you would probably feel terribly and maybe vomit later on. There were like 4 groups with 10 people, and so like 40 people in total, and 3 of them actually vomited during the flight. By the way, we also got some pills in order to not vomit, but you didn't have to take it. Yeah. And you know, in like Martian or lunar gravity, we were basically trying to do push-ups. Like someone was sitting on your back, and you could do push-ups with just one hand or something. We also had some kind of water experiment during one of the parabolas. So there was like water balloons that were, you know, the water was there, spilled, and it was flying, and you could drink it or something. We also had some balls to play with, or you can see me here on the top trying to, well, I don't know, do something. We also had some kind of, you know, things just to make nice photos. So here we made some wave where when we started at the, you know, at the ground level, and someone pushed us upper to make the wave. Yeah, and at the very end we also had some kind of dinner with like the whole company or the crew that was there with us, and the CEO of the company, so we could ask questions about the stuff, like, you know, any questions, how much does it cost, does it make sense to make such a business? Probably not really, because it's, well, expensive and you need all the regulations and stuff, and, you know, they are under some kind of space agency, so it's much easier for them. But yeah, that was it. I recommend you doing it. Nobody pays me for any kind of, you know, advertisement here, but it was nice. Yeah, so my third lightning talk is about Interstellar movie. Have anyone watched it? Yeah, most of you did. So I recently found out that actually when they were creating the movie, they actually created a research paper on gravitational lensing by spinning black holes in astrophysics and in the movie Interstellar. They did it because they wanted to have like a proper image of a spinning black hole or something. And it turned out that people didn't really know how to do it, like how such an image would look like. So they implemented or developed some kind of code called a double negative gravitational renderer to solve the equations for ray bundle light beam propagation through the curved spacetime of a spinning black hole, and then to render it in IMAX quality, obviously. So that was it for my lightning talks. And if you wanted to see any of those slides, you can find them on uyep.link/disco. And also don't forget to register and play in the teaser CTF. By the way, we will also have finals on the hackathon in September, which will be open free for all. And we will also have like special prizes for academic teams. So that's it. Thank you.
Okay, thank you. Can we have the first lightning talk presenter come downstairs? I know we didn't agree for any order, but whoever is ready. Okay. W sumie nie wiem, czemu mówię po angielsku. Przez ciebie mówię po angielsku. Dzięki. Co potrzebujesz, żeby się wypowiedzieć?
Chodźcie do HDMI? Tak. Najpierw to?
A, to HDMI nawet.
Komputerek?
Tak, drugi lightning talk. Pierwszy, który nie jest Dominikiem lightning talk.
W kieszeni może być? Może być, dobra. Po prawej stronie jest. Nie, HDMI musi być, bo to jest starość. Tu jest chyba HDMI. No.
Kiedy idziemy?
Ja jestem Bartek, albo pokerface'owaty. Jeśli każdy tu coś reprezentuje, ja wolałbym nie reprezentować swoich pracodawców. Powiem, że jestem z Fundacji Gramy Szybko, Pomagamy Skutecznie. Jestem jej prezesem. I jeśli nie słyszeliście nigdy o GSPS-ie, zapraszamy na gsps.pl. Robimy co pół roku maratony charytatywne speedrunningowe. Speedrunning to przechodzenie gier jak najszybciej. Co pół roku spotykamy się, żeby pokazać parę dni speedrunningu w zamian za wpłaty na cele charytatywne. A ja dzisiaj chciałem pogadać o tym, że kupiłem sobie zegarek. To może brzmieć jak nic specjalnego, dziękuję bardzo. Dziękuję, do widzenia, koniec. Chciałem się po prostu pochwalić, ale chciałem mieć znowu zegarek po prostu, żeby mieć czas na ręce. Koniec, jakby nic więcej. Lubiłem swojego Casio, rozwalił się 2 lata temu, przez cały czas myślałem, że chcę zegarek. Zacząłem sprawdzać, czy potrzebuję smartwatcha i generalnie, jeśli człowiek się zastanawia, czy potrzebuje smartwatcha, to odpowiedź brzmi nie. I tak jest w moim przypadku, jakby serio mogę wyciągnąć telefon z kieszeni, żeby im zapłacić, dam sobie radę. Więc tym bardziej, że trzeba wydawać na to grube pieniądze. Ale zacząłem przy okazji szukać, czy nie ma jakichś niesamowitych, inspirujących projektów związanych ze smartwatchami, bo jak jest tyle hype'u na smartwatche, to może jest coś ciekawego. I większość z nich Espruino z bajerami, nie Espruino o tym zaraz, Arduino z bajerami. Natomiast kupiłem sobie Bangle.js2 i teraz jakby zaczyna się hejt na tę część o JS-ie. Lubię, kiedy rzeczy są smart, kiedy rzeczy są smart tak jak chcę, żeby były smart. I teraz, to jest część projektu Espruino. Espruino to jest interpreter JavaScripta na mikrokontrolery. Niedźwiedziujcie ze mną. nie jest tak złe, jak się wydaje. W każdym razie pomysł generalnie jest taki, że jest to otwarty jest to otwarta konstrukcja, czyli jakby i software, czyli interpreter napisany w C jest otwarty i hardware jest otwarty. Nie mam pojęcia, jak działa otwarty hardware, ale podobno jest otwarty. Całość była na Kickstarterze, więc jest to część tego projektu. I teraz jedna z rzeczy, którą możecie sobie pomyśleć, no to spoko, no to wszystko sobie muszę napisać w JavaScriptie, tak jakby mam czas i to tyle. No i tu jest miłe zaskoczenie, nawet dla mnie. Mają uploader i ten uploader to jest 500 apek napisanych przez społeczność. Apki to tak jakby wiadomo, od 10 linijek, które pokazują ci czas do, nie wiem, 1000, które robią coś bardziej skomplikowanego. Generalnie ta maszyna nie ma zbyt dużych możliwości, bo to jest 8 mega pamięci i jakby nie jest to nie wiadomo co, ale jednocześnie ważna rzecz, mam wypisane punkty, o których chcę powiedzieć, ale nie w kolejności, a tu mi pasuje. Kiedy wyjmiecie go z pudełka, i to jest zajebista rzecz w porównaniu do na przykład Apple Watcha, kiedy wyciągniecie go z pudełka, to bazowo bateria trzyma 4 tygodnie. I dopiero przez odpalanie na nim kodu powoli zmniejszacie sobie ten poziom do takiego, jaki chcecie, no nie chcecie, do jaki jesteście w stanie znieść. Ale generalnie to działa tak, że od razu macie 4 tygodnie. Jak chcecie widzieć każdą sekundę na czasie zamiast minuty, to macie 2 tygodnie. I tak dalej, i tak dalej. Natomiast fajnie, że jest App Store i App Store to nie jest nic specjalnego, to jest tylko repo na GitHubie. Tam po prostu jest kod, jeden plik z metadanymi, jeden plik z ustawieniami i to wszystko. Jeśli chcecie wrzucić coś na App Store'a, po prostu robicie pull request. Więc nawet jakby dla ludzi, którzy 3 tygodnie temu zaczęli się uczyć JavaScripta, da się zrobić rzeczy. I nie wiem jak wy, ale ja jak mam nową zabawkę, bo umówmy się, to w pewnym sensie jest dla mnie zabawka, a nie jakby coś bardzo poważnego, bo tak jak mówiłem, chciałem tylko czas na ręce, a reszta to tylko dodatki. Nie wiem, czy to tak macie, ale jak ćwiczę nową technologię albo nie wiem, nowego języka, to lubię zrobić coś głupiego. Jak zrobię coś użytecznego i mi nie wyjdzie, to będę zdenerwowany, że zmarnowałem czas. A tak to jak to jakaś głupota nie wyjdzie, to palone. Jak się uczyłem pisać podstawowego kernela do modułu do podstawowego modułu do kernela, to napisałem moduł, który sprawdza, czy dzisiaj jest piątek. Bo po co będę pisał od razu jakiś sterownik, który nie wyjdzie. Więc to jest moja początkowa wersja. Idealnie chcę, że kiedy odblokuję zegarek, to jest emulator. To dwie paletki grają od teraz ze sobą w Ponga. I wynik jest bardzo mały, ale generalnie bardzo proste odbijanie piłki. One tylko sprawdzają, czy piłka jest ponad nimi, czy poniżej i mają jakąś tam zakodowane opóźnienie w przesuwaniu się. W każdym razie fajnie, że jedna z rzeczy, która doznałem olśnienia po tygodniu używania go, zacząłem się nim bawić i pomyślałem, okej, no podłączyłem go sobie do telefonu, iOS działa tak, że można Bluetoothem wysyłać, jeśli się podepnie coś po Bluetoothie, to można wysyłać tam wszystkie powiadomienia, więc część powiadomień to po prostu pokazuje wam się na zegarku, mają limit ruchów, więc za chwilę się skończą, ale część powiadomień po prostu pokazuje wam się na zegarku, właściwie wszystkie, ale niektóre z nich możecie powiedzieć w integracji, jakby to powiadomienie miało to w sobie, to go nie pokazuje jako powiadomienie, tylko zapisz to gdzieś, jak na przykład do kalendarza. Synkowanie kalendarza działa tak, że raz dziennie puszczam sobie wszystkie elementy z kalendarza jako powiadomienia. Na wyciszeniu, żebym tego nie widział, ale jednocześnie jakby tak to działa. I przez to miałem olśnienie pod tytułem dostałem powiadomienie, którego nie chciałem zobaczyć na zegarku i pomyślałem, cholera, jakby, czyli teraz albo włączę wszystkie powiadomienia, albo wyłączę wszystkie i teraz jakby albo mi będzie wibrowała ręka cały czas, albo nigdy. I pomyślałem, nie, bo integracja z iOS-em to 300 linijek JavaScripta i można tam napisać, jak to nie jest kalendarz, to spieprzaj. To po prostu jest bardzo miła myśl, nawet jeśli jakby nie używa się tego do maksymalnych możliwości, to bardzo miło mieć taki wybór. I dla wszystkich narzekaczy, bo wiem, że wszyscy po prostu siedzą teraz i myślą, Jezus Maria, ten JavaScript jakby mi też się nie podoba, piszę dużo w TypeScriptie i JavaScript czysty to jest koszmar, ale dla wszystkich takich właśnie narzekaczy jak wy, którzy tylko widzą coś takiego i myślą, już by wystawili palec i powiedzieli, JavaScript mi się nie podoba. Jest funkcja, moi drodzy, która nazywa się i teraz mi uciekło, bo zmieniłem rozmiar ekranu, super. Która nazywa się Compiled C. Więc jeśli bardzo wam przeszkadza JavaScript, to wpakujecie w funkcję dowolną ilość w tekście C i przez trochę magii kombinowania dostajecie faktyczny kod maszynowy, ponieważ no jakby ta maszyna ma za mało soczku, żeby tak po prostu skompilować C, więc to jest wysyłane do ich serwerów w momencie, jak pakujecie to przez IDE, przez Bluetootha i po prostu bytecode jest wysyłany z powrotem do waszego zegarka. To tyle. Pewnie najważniejsza rzecz, 70 funtów albo 80 funtów. Ze sprowadzeniem tego do Polski to jakieś 500, więc jakby jak na powyżej smartbanda, a poniżej smartwatcha, cenowo się zgadza. I to chyba tyle. Dzięki.
A ja mam takie pytanie jeszcze do tego.
Tak.
A czy jest integracja do Pythona do tego?
Jak sobie zrobisz transpiler Pythona z JavaScripta, to na JavaScripta nie ma problemu.
A obsługuje WebAssembly?
Obsługuje zwykłe assembly. W sensie oprócz tego, że możesz tam dawać kompilowane C, znaczy możesz kompilować C, to możesz też napisać w assembly, jak się bardzo chcesz uprzeć.
A zmieszczę tam całego CPythona?
8 mega pamięci, nie wiem ile zajmuje CPython.
To chyba nie, dzięki.
Wyciszać czy jakoś? Nie.
Okej, włączone. Dobra, zegar jest. Zegar działa?
Rusznie jak zaczniesz.
Okej. Dobra. O. Tak? Git. Dobra. Cześć, jestem Szymon i trochę pokażę ostatni fajny bajer, który wykminiłem w FastAPI. Przykładowa apka, jakieś 3 modele, jakiś model item, który mogę powiększyć. Rozjaśnić chyba nie mogę, ale mogę powiększyć. Model item z jakimś name'em, model engine i jakaś klasa car, 4 endpointy na krzyż, nic specjalnego. Ważny feature FastAPI, Swagger, autogenerowana dokumentacja. Tutaj widzimy wszystkie endpointy, widzimy schemę. Mało kto wie, że jest jeszcze inna templatka, redoc. Jest też automatycznie inkludowana w FastAPI pod /redoc. I jeszcze mniej ludzi o tym przynajmniej tak mi się wydaje, że pod /openapi.json jest generowany plik JSON, który zawiera całego JSON-a, na podstawie którego jest ta automatyczna dokumentacja generowana. I teraz, do czego nam się to może przydać? Powiedzmy, że były sobie te dwie klasy, car i engine, no i teraz chcemy, aby każdy item zawierał jeszcze kolor. Więc radośnie sobie dodajemy atrybut color. Jak mi powiesz, jak wyłączyć night mode, to zrobię. Pop OS. Dobra. W displays? Lepiej. Więcej niż Full HD. Dobra, więc dodałem sobie kolor. Tutaj mi serwer cały czas działa, więc widzę sobie to API, odświeżam. No i super. Pojawił się mi atrybut kolor w samochodzie, ale to, czego tutaj nie widać, to to, że w engine też się pojawił. Więc to jest taka kwestia jakby, że możemy sobie dorzucić coś do schemy i coś inne dziedziczące po tym, nagle się nam pojawia jakiś dodatkowy atrybut w API. I na pierwszy rzut oka nie zawsze to można zobaczyć, ale gdzie to fajnie widać, to w OpenAPI, gdzie faktycznie pojawia się nam ładnie schema car, pojawia się nam nowy atrybut color, no i to samo się stało w engine. I teraz moim problemem było to, jak wziąć i sprawdzić, co się zmieni, kiedy ja dodam jakiś atrybut albo coś zmienię. Więc pomyślałem sobie, ok, będę trzymał w repo snapshot OpenAPI. I zrobiłem to przez taką lipkę, która się nazywa SyruPy, sorry. I to jest tyle. 3 linijki kodu. I teraz jak odpalę sobie teścik, to w folderze z nazwą pliku testowego, z nazwą modułu, gdzie są testy, pojawia się mi plik OpenAPI.json. Jest super, bo mam to w repo. No i teraz jeżeli sobie coś zmienię i odpalę ten test ponownie, no to się mi... Dobra, zrobiłem snapshot, więc się mi nie wywaliło. Ale teraz widzę przynajmniej, jak sobie zrobię diffa, tutaj, jak sobie zrobię diffa, to widzę, że coś mi z tej skimy zniknęło. Trochę lepsza wariacja to nie snapshotowanie całego OpenAPI.json, bo jak więcej osób nad tym pracuje, to konflikty, nikt nie lubi konfliktów i nikt nie lubi ich rozwiązywać. I to jest plus, że fajnie to widać później przy code review. Można sobie wziąć i przeiterować się osobno po wszystkich endpointach i osobno po wszystkich skimach, które mamy. No i jak mamy sobie taką pętelkę, to wtedy generują się nam pliki, osobno plik dla każdego endpointu, osobno plik dla każdej skimy. Więc teraz jak odpalimy sobie test split, no to zobaczymy, które skimy się nam zmieniły przez dodanie jakiegoś innego obiektu. I to jest jeden z use case'ów. Drugi z use case'ów, jaki znalazłem, to jeżeli mamy sobie jakieś na przykład common paramsy z dokumentacji FastAPI, no i wrzucimy sobie te common paramsy do endpointu, puścimy sobie zupdate'owanie, tych snapshotów. Cyk, cyk, cyk. OK. No to zobaczymy, że się nam pojawiły w skimie. Jakby nic specjalnego. Ale jeżeli weźmiemy i dorzucimy sobie na przykład do nich description, z jakiegoś powodu chcemy mieć description, bo common paramsy A i B nam nic nie mówią. Cyk. I w takim przypadku akurat to jest mało znany, nie nazwałbym tego bugiem, bardziej nieintuicyjnym działaniem FastAPI, że jeżeli wstrzykujemy common paramsy przez depensa, to description się nam nie łapie. Takie coś w przypadku snapshotowania wyłapiemy, bo tego description tutaj nie widać. Nie generuje się nam w OpenAPI. I jeszcze trzeci case, jaki znalazłem, ale to już szybko. Jeżeli będziemy mieli data klasę i będziemy sobie mieli model pydanticowy, który dziedziczy z tej data klasy, to nie potrzebujemy tych atrybutów. I chcemy sprawdzić hipotezę, czy jak podmienimy sobie coś, w sensie nie definiujemy takich parametrów na pydanticowym modelu, tylko dziedziczymy z data klasy, puszczamy sobie znowu testy snapshotowe. No i widzimy, że praktycznie nic się w tym nie zmieniło poza kolejnością atrybutów. Więc tak podsumowując, to jest fajny sposób, żeby trzymać sobie skimę całego API w repozytorium i fajnie sprawdzać, co się zmienia, jeżeli zmieniamy coś w kodzie w nieoczywisty sposób. Tyle. Dzięki.
Dzięki. Jesteśmy blisko końca dzisiejszego spotkania. Jeszcze ja mam dla Was krótkiego lightning talka od siebie. Okej. Już sobie tylko zobaczę. Dobra. Dobra, to ja mam dzisiaj Lightning Talka dla was, który dokądś zmierza. I ja to zaznaczam pierwsze, żeby nie było takiego wrażenia, że przyszedłem tutaj i sobie robię wspominki, ale zainspirowało mnie do zrobienia tego Lightning Talka to, o czym wspomniałem na początku, czyli że w sumie to nawet nie wiem, ile lat ma Pykonik. I chciałem przejść sobie trochę taką historią Pykonika z wami, tym bardziej, że wiem, że jest tutaj też trochę nowych twarzy, które może to być po prostu ciekawe, skąd się wziął ten Pykonik. Pykonik w swojej historii przeszedł sporo miejsc i wydarzeń. Od stosunkowo niedawna jesteśmy tutaj na Politechnice, czasem bywamy na AGH-u. W poprzednich latach bardzo często bywaliśmy w biurze Spoton, które było partnerem Pykonika przez lata. Tutaj na przykład widać, że ludzie od kabli niekoniecznie się zmienili. Piotrek na stanowisko od samego początku. W 2020 na przykład cały czas prowadziliśmy spotkania TikTokowe w CodeCoolu. Bardzo fajna przestrzeń. Niektórzy prelegenci również się nie zmienili, jak widać. Co jest ciekawsze, data 30 stycznia 2020. Wszyscy wiemy, co się wydarzyło mniej więcej niedługo później. O czym możecie nie wiedzieć, Pykonik działał na początku pandemii, robiąc spotkania online i to były dość ciekawe spotkania, bo nawet udawało nam się zorganizować międzynarodowych prelegentów. Więc całą pandemię gdzieś, no nie całą, bo początek gdzieś próbowaliśmy działać i tym bardziej się cieszę, że teraz wracamy z tymi spotkaniami do coraz bardziej regularnej, do coraz bardziej regularnych spotkań. Co było wcześniej? W 2019 roku na przykład mieliśmy pierwsze spotkanie z serii Pykonik i nie było ich za wiele, ale też zdarzało nam się spotykać nieoficjalnie po prostu na piwo, gdzie rozmawialiśmy sobie o Pythonie. Jeszcze wcześniej, w 2017 w ogóle wystartowała nasza strona Meetup, który był zapożyczony z Warszawy, z warszawskich spotkań PyWaw. No i od 2017 roku mamy naszą ładną stronę, gdzie wszystko publikujemy. Dlatego na Meetupu widzicie pewne odcięcie w historii i ono jest na 33 TikTokach, przypomnę, dzisiaj mamy 70. Dlatego, że w 2017 roku nasze spotkania jeszcze są na blog pykonik.org i ta strona o dziwo dalej żyje. Nie ma skonfigurowanego HTTPS-a, ale jest, więc można dojść do historycznych spotkań Pykonika, jakby komuś zależało. Wracając jeszcze do innych form spotkań, mieliśmy też bardzo długą serię spotkań typu Open Space, gdzie rozmawialiśmy w krótkich pulach na tematy zaproponowane przez uczestników, czyli sami się spotykaliśmy, proponowaliśmy tematy, to była bardziej otwarta forma. Było to całkiem ciekawe i też jeszcze powiem, dlaczego do tego wracam. W sumie mogę od razu powiedzieć. Dzisiaj kończymy nasz sezon na ten rok, bo zazwyczaj na wakacje robimy przerwę, ale w przyszłym roku ruszamy z nowym sezonem i jeżeli ktoś z was chciałby się zaangażować w Pykonik, na pewno wrzucimy na Discorda takie pytanie, bo jesteśmy otwarci na różne formy. Robiliśmy też kiedyś dojo, gdzie wspólnie programowaliśmy, robiliśmy właśnie te open space'y. Jakby jest na to przestrzeń, żeby więcej rodzajów spotkań markować tym Pykonikiem, bo to trafia po prostu do ludzi, a w koniec końców wszystkim nam, organizatorom, zawsze chodzi o to, żeby po prostu angażować ludzi i poszerzać wiedzę. Dobra, ale co przed tym 2016? Pochwalę się osobistą wrzutką. W 2012 prowadziłem swoją pierwszą prezentację w życiu. Pamiętam, że byłem cholernie zestresowany, bo w ogóle nie wiedziałem, jak mówić publicznie. I nawet jest to na YouTubie. Znalazłem to dzisiaj, więc jeszcze nie przesłuchiwałem, ale aż się boję tego słuchać, naprawdę. I w 2008, 10 stycznia, był pierwszy Pykonik. Pierwsze spotkanie na blog pykonik.org, jak się kliknie wstecz kilka razy, można tego dojść. I to, co mnie tym bardziej zaciekawiło, to sekcja komentarzy, bo na przykład można się tam dowiedzieć, że Pykonik jeszcze wtedy nie był Pykonikiem, tylko trwało wymyślanie nazwy, na przykład Krakowska Liga Entuzjastów Pythona, Klepka. Chyba się cieszę, że nie zostaliśmy przy tej nazwie, bo na szczęście użytkownik Wardo zaproponował Pykonik jako nazwę w 2008 roku. No i jak widać, ta nazwa została na 16 lat, 5 miesięcy i 3 dni, czyli 6000 dni temu. Ile było spotkań? To też mi się udało teraz na szybko podsumować. 70 tech talków, 11 open space'ów, 16 coding dojo, 2 piwkoniki i 1 meet-py sprint, który też nam się kiedyś udało zorganizować deployed. To czy ktoś już sobie podsumował te liczby w głowie? Dzisiaj mamy 100. Pykonik. I to jest to, do czego zmierzam. Zupełnie przypadkiem, nikt tego nie liczył, ale witam na 100. Pykoniku.
Ale przepraszam bardzo, ale ten slajd się nie zgadza. No bo to jest 100 silnia.
Wiedziałem. Specjalnie dałem ten wykrzyknik, żeby ktoś mógł się przyczepić. Więc w związku z tym chciałem wrócić do pytania. Kto w takim razie wybiera się dzisiaj na afterparty? Dobrze, to jeszcze teraz wrzucę kolejny slajd, bo dzięki uprzejmości Kluga z okazji rocznicy dzisiaj mamy open bar na afterparty, więc wielkie brawa dla Kluga. To kto się wybiera na to afterparty? Wiedziałem, że to bardziej zaangażuje. Tyle z oficjalnej części 100. Pykonika. Ja jeszcze przejdę do części związanej z domknięciem spotkania dzisiejszego. Tak. Czyli co dzisiaj było za nami? Przede wszystkim jeszcze raz chciałem podziękować. Zróbmy to, żeby przejść sprawnie pojedynczym klapnięciem rąk partnerom i sponsorom. Sponsorami dzisiaj jest Vatix, JetBrains, partnerami jest Cosmo PK oraz Klug. I tutaj jest jeszcze jedna wzmianka, partner, o którym nie wspomniałem, ale teraz powiem 2 słowa, jeszcze możecie się wstrzymać. Pycom.pl, jesteśmy jednym z patronów Pycom.pl, więc zachęcamy do udziału w tej konferencji. Mamy długą wspólną historię kooperacji z Pyconem.pl, więc 29 września do 1 sierpnia na Śląsku, nie pamiętam miejscowości, Gliwice, odbywa się Pycom.pl i gorąco zachęcamy do udziału w tej konferencji. Też dla nich klapnięcie. Dobra, udało się nawet zgrać. Gdzie nas znaleźć? Pykonik.org, nasza ładna nowa strona. Jak znajdziecie blog Pykonik.org, to nie, tam nie będzie już żadnych informacji, prawdopodobnie nigdy. Discord Pykonik.org. I jeszcze chciałem przejść do rozwiązania konkursu. Zawsze to robię w taki sposób. Nie przełączaj. Przepraszam. Tu Pykonik 70. Mamy 4 łapki w górę. Don Polako. Jest tutaj Don Polako. Czy chcesz licencję PyCharma? Dobra, super. To dostaniesz wiadomość. I druga wiadomość. Paweł. Jest tu Paweł. Czy chcesz licencję PyCharma? No i super. I mamy rozwiązany konkurs. I to jest tyle z oficjalnej części. Dziękuję wszystkim za udział w 100. Pykoniku. Dziękuję słuchaczom na streamie i za mną można się udawać na afterparty za jakieś 2-3 minuty, a chłopaki tutaj ogarną całą przestrzeń. Dzięki wielkie.